Okay, so example 1 for chapter 7.2. What is the measure of the angle in standard position whose terminal side passes through the point negative 3, 4? I think we got a few words in here you've never seen before, right? First off, standard position, you probably don't know what that is. You see the words terminal side. Probably don't know what that means either, so let me go through a little vocabulary with you on this problem. First off, when we're dealing with trigonometric numbers, angles in trigonometry, we typically stay between 0 and 360 degrees in our angles. So far we've only done acute angles, but as we delve deeper into trigonometry, we're going to allow ourselves to go all the way up to 360 degrees. We're going to be using what's called the unit circle at some point, and when you're considering trigonometry, those that came up with the idea of trigonometry made a few standard ideas out of it that allow us to have consistency in the study of this. So, when we're talking about standard position, we have a ray. Got to figure out how this board works. Give me a second. That's that. I want that thin. I want it blue. Maybe I've got to make that go away. So, we have a ray that is at the origin going to the right. The positive x-axis is what this is known as. All right. And anytime anybody talks about the positive x-axis, they mean start at 0 and go that way. They say the positive y-axis, they mean start at 0 and go straight up. All right, that's what they mean. But this right here, this ray, is going to be the initial side of every angle in standard position. Oops. Seriously? Just want to erase. There we go. When they say an angle is in a standard position, the initial side is positive x-axis. An angle has two sides, one ray and a second ray. All right? The terminal side would be where it opens up to. So it passes the point negative 3, 4. So if I were to plot negative 3, 4, the other side of this particular angle passes through that point. So I'm going to start at the origin, and I'm going to go through that point, creating an angle. So the initial side is this. Where the angle ends up is called the terminal side. And again, the vocabulary is important here so you know how to identify what we're talking about. Now, the angle right here is the angle in question. The angle always goes from the initial side counterclockwise to the terminal side. Okay? There's two directions to go when we're dealing with angles in the unit circle idea. 0 degrees is straight right, 90 degrees is straight up, 180 degrees straight left, 270 degrees straight down, back to 360 degrees straight right again. That's how we work our way around the unit, around this idea, this circular idea. All right. When we go this direction with an angle, that's a positive direction. If we go the other direction, that's a negative direction. All right. So, if this way would be negative, this way is positive. All right. So, keeping that in mind. Now our task is to find the measure of the angle in standard position whose terminal side passes through that point. So let's take a look at this. Is everybody okay with all the words here? I'm about to erase them so I have room to work. Let me get all the words down. So again, this is the initial side. The initial side is always that. If it says standard position, that's always the initial side. The initial side never does anything but start there and go that way. That's the initial side. And the terminal side is where it opens up to. That's where it ends, and it goes through this point. That's what it told me. So again, that's how I drew the picture, by the description of the problem. All right, now, to find this angle measure, I'm going to use trigonometry. And the only trigonometry I know right now is SOHCAHTOA, right? So I have to stay within our own toolbox here that we have, which is trigonometry. So I'm going to draw in what's called a reference triangle. reference triangle green. Okay, I happen to know this point right here is negative 3, 4. I'm going to draw from the point straight to the x-axis. Now, depending on where you're at, okay, if I'm in the second quadrant here, I got to go down to get to this x-axis. If it were all the way over here, if the terminal point was negative 3, negative 4, and it came down here, then I'd want to draw up to the x-axis. You always want to go from the terminal point, from whatever the point they give you, you want to draw a vertical line to the x-axis, whichever direction that is. So again, if I'm down here, I got to go up to get to the x-axis. If I'm over here, I got to go down to get to the x-axis. Over here, up, right? But we're always going to the x-axis. We want that to be at a right angle to the x-axis. And I'm going to make this reference angle right here, which is part of this triangle. I'm going to call this angle, let's call it alpha to give it a name. Alpha looks like a fish. Again, my task is to find the measure of this angle. I can use SOHCAHTOA to find this angle. Notice that this length is 3, by counting 1, 2, 3. This length is 4. This length is 5. How do I know that's 5?
The pairs.
What?
The triples.
Pythagorean triples, 3, 4, 5. Otherwise, Pythagorean theorem. Leg squared plus leg squared, 9 plus 16 is 25. The square root of 25 is 5. But again, more often than not, the book sticks to Pythagorean triples. So be expecting Pythagorean triples, 5, 12, 13, 8, 15, 17, 3, 4, 5, and so on. So 3, 4, 5. For alpha, my reference angle, 4 is the opposite side, 3 is the adjacent side, and 5 is the hypotenuse. And we should be getting pretty good at figuring out those 3 every single time, right? So looking at alpha, if I want to figure out how big alpha is, and looking at SOHCAHTOA, I know all 3 sides. All 3 sides are exactly those measures, 3, 4, and 5. So any one of those 3 trig functions will give me the exact same answer. It doesn't matter which one I use. All right, just to demonstrate though, if I was using sine, it would say this: sine of alpha, because we don't know alpha, equals opposite, which is 4 over hypotenuse 5. If I used cosine, cosine of alpha equals adjacent 3 over hypotenuse 5, 3/5. If I used tangent, tangent of alpha equals opposite over adjacent, opposite 4 over adjacent 3, 4/3. So if I'm using the sine one, alpha is going to be inverse sine of 4/5. If I'm using cosine, cosine of alpha, so alpha would be inverse cosine of 3/5. If I'm using tangent of alpha, so alpha equals inverse tangent of 4/3. I don't have to use all 3 because again, all 3 are going to have the exact same answer. All right, and you'll have to believe me, I got a calculator here. I don't have one on the screen anymore. So if I do inverse sine of 4/5, my calculator says alpha equals 53.13 degrees. If I do inverse cosine of 3/5, my calculator says alpha equals 53.13 degrees. If I do inverse tangent of 4/3, my calculator says alpha equals 53.13 degrees. I'll pass it around. You guys can look to verify I'm not breaking any rules. Here you go. Pass it around, let everybody see it. So notice it didn't matter. I could do inverse sine, inverse cosine, inverse tangent. It doesn't matter. You pick what you want, do it, and you'll get the answer, because that is what it is. That's what alpha equals. No matter if you use sine, cosine, or tangent, we know all 3 sides are all exactly right. The answers, the calculator will spit out the exact same answer, because that's what the answer is. So now, once I know alpha is 53.13 degrees, My task is to find theta. Okay, take a look at the two angles alpha and theta in this particular picture. Alpha lives right here, theta lives right here. How do these two angles relate to one another?
180 minus alpha is theta.
Okay. 180 minus alpha is theta. That's the next step beyond the relationship. The relationship is they make a straight line, right? And if they make a straight line, they add up to 180. So I know that alpha plus theta is equal to 180 degrees in this particular picture. All right? So like Daniel said, once we know alpha plus theta equals 180, that means theta equals 180 minus alpha. All right? So, we figured out what alpha was. We're trying to find theta. Alpha and theta make 180. Alpha plus theta is 180, so theta is 180 minus alpha. So theta equals 180 minus 53.13. So theta is equal to 126.87 degrees. And it is positive because we went in a positive direction. Now, for your notes in your paper, on your paper here, somewhere in that open space, I want you to put these 4 facts. If the reference angle's alpha, quadrant 1, theta equals alpha. Quadrant 2, theta equals 180 minus alpha. Quadrant 3, theta equals 180 plus alpha. And quadrant 4, theta equals 360 minus alpha. This problem only dealt with the second quadrant angle, but that's the relationship with the reference angle in each case. For example, if alpha were in the third quadrant here, if this were alpha here, 180 degrees plus alpha would be theta. Okay, so that's just how the alpha and theta relate to one another. So every single time you do this, you're going to draw this reference triangle. You're going to get this reference angle alpha that's over here at the origin every single time. You're going to have sine, cosine, or tangent to get the angle measure alpha. This is how you find the theta off the alpha every single time, depending on what quadrant you're in. The first quadrant is right here. The second quadrant is there. The third quadrant is here. And the fourth quadrant is there, in case you've forgotten that from previous classes.